Hi, hello, welcome to Ecstasy Software Solution. Today we are going to see about the project called an improved weapons detection and classification system. Mostly archaeologists dig and excavate a lot about the old weapons and they will identify those weapons and what are the names of the weapons. So this process is done by manual assumptions where this will be more complex to identify the weapons. So here we have a base paper where this base paper will identify the weapons and it will classify what are the weapons they are. So in this existing paper, the weapons will be identified by using some mock attack data set, and also the complete features of the image will be identified using RCNN, faster RCNN. So they have used many algorithms like Inception, ResNet, MobileNet, YOLO, etc. So now what I'm going to use here is I'm just going to identify the weapon, and also I'll be identify the year of the weapon. So here is a main complex identification where the names of the weapons can be easily identified by the archaeologists, but identifying the year is the major problem. So I'm just going to create a software where it identifies the weapon and the year also. Okay, so here I'll be using the same CNN identification where it will be more enhanced. So this is my project and I'm just going to run my project. So my project is loading. So as usual, as I said, I have used CNN with MLP. So as we already know, CNN is convolution neural network and MLP is nothing but multiple layer perceptron. So in CNN I have added MLP, which gives the exact result to identify the exact feature of the weapons and year too. So here this domain is completely based on deep learning with machine learning. Here a supervised classification has been done where a training and testing process will be added too. So yes, this is the home page. So now I'm going to make a data training. So I'll be inserting, consider myself as an admin, and I'll be training some data. So this is my weapon and I'll be training like some pre-processing methods will be used where grayscale conversion will be identified, noise removal, and morphological processing. Morphological processing is nothing but identifying the size of the image and getting the feature. So it will exactly get the texture, size, and exactly the outlines of the image. So after that, feature extraction, here I got a feature extraction. So after here I'll be training the year and description. If we getting any weapon, so if this is the weapon, I'll be using a pre-trained model. So I'm just giving a year 1920 and the description. Okay, so now I'm giving the name of the weapon in description and also the year. So I'll be training more than 10,000 images here. So these features will be added here and it will be uploaded success. So these are the models. You can see the models in the left side where image acquisition is the first model, grayscale conversion of an image, noise removal is the third model, morphological identification is the fourth one, feature extraction is the fifth, and the training process is the sixth. So combining these 6 modules, the training will be done and the upload of these training images will be processed. So more than I need to add each and every image of where it should be add with SWOT, it should be add with guns, etc. so that it can differentiate those things, and with the identifying the color variations of the image, the years will be classified. So now I'm just closing it. I'm going for testing process. So moreover, in existing system they have identified the weapons only, but in my proposed system I'm going to identify the year, which as I said before, year identification is the common problem, right? So now I'm rerunning my project to identify the test cases. So I have already trained more than 12,000 images, and I'm going to make a test over any image, or I'm going to input an image like image acquisition. It will identify the feature as in the training process, and it will identify what from which year it is from and a description of the concerned weapon. Okay, yes, it got pop up. So I'm going for testing, and I'm going to select an image. So I'm giving this word. Okay, so this is the identified weapon, and if I'm going for the classification system, it will identify the weapon as predefined trained process. So here the year is 1934. The description is this is a kind of sword used for emergency purpose by women in 1934 AD. Okay, so this is the complete process which I trained before, and will identify the year too. So using convolution neural network, the feature extracted will be done, and using the MLP, the exact layer will be identified, and it will give the classification result. Okay, so this is the process. So in existing they have used faster RCNN, and in my proposed I have used CNN with MLP. So this gives the exact accuracy compared to the existing system. So this is the accuracy plot, where in existing system it just gives 46.1. So for my proposed system, until the data tested, it gives 60%. Okay, so this will be the best upon this faster RCNN in the existing paper. This CNN with MLP gives the best identification of the weapon with the year. So this project gives the best timings too, where existing will be 35 seconds, and the proposed will be nearly 1 second to 2 seconds only. It's 1.1 second. So this project will be efficient to identify the year of the weapon, and if we give the software to the archaeologists, they can easily identify the year of the weapons and the description of the weapons as pre-trained. So this is supervised classification, and it will down towards to deep learning analysis, where the complete identification of the weapon will be more and more accurate, up to 60%. Okay, so if you have any doubt, kindly call us on the below number. The abstract is mentioned below. If you want the project, kindly call us. Thank you.